Hello, my dear students. I am Dr. Dharmendra Tyagi, Associate Professor, Mechanical Engineering Department, the SIRT, the SAGE Group, Bhopal. Today, we are going to discuss about the analytical method for velocity and acceleration of the piston. We will start from the introduction. The dynamic analysis or dynamic forces are associated with accelerating masses. All machines have accelerating parts. The dynamic forces are always present when the machine parts operated or machines operated. In situation where the dynamic forces are dominant, the dynamic analysis has to be carried out. So for this, we have to calculate the displacement and velocity and acceleration of the piston. Now we consider the motion of a crank and connecting rod of a reciprocating steam engine as shown in figure. Here you can see this is the crank, this one is the connecting rod, and here is the piston, which is which is represented by point P. And the motion of the piston from P to P dash, and this distance traveled from P to P dash, that is called displacement. This is represented by small x. And the length of the connecting rod is represented by small l. And the length of the crank, which is represented by small r. And this is the crank angle theta. And here the angle of the connecting rod with the line of stroke, that is phi. These are the terms. The length L, length of the connecting rod between the centers, or radius of the crank or crank pin circle. Phi, the inclination of connecting rod to the line of stroke. And here is the small n. It is small n, that is equals to L upon R, which is the ratio of the length of the connecting rod to the crank radius. Now, from the geometry, we can see the value of the x, that is equals to P dash. That means the distance between the P to P dash, that is equals to x. X is the displacement of the piston. It can also be written as O P dash minus O P. That means from here, distance from OP dash minus distance OP. So after that, the difference of this will give P dash. That means the x, which is displacement. Then the OP dash can also be written as P dash C dash plus C dash O dash. This is written here, minus OP can also be written here, P Q plus Q O. Again, P Q plus Q O. So this is also written here. So this is the displacement of the piston. So from the geometry, we can substitute the value of P dash, C dash, C dash O, P Q, and Q O. So here you can see that the value of P dash, C dash. The P dash, C dash, that means P dash and C dash. This is the L. When that means the piston, position of the piston at point P dash. That means this is the length of the connecting rod, and this is the crank, length of the crank. So here you can see this is the L from P dash to C dash, and from C dash to O, that is equals to R, that is length of crank, that is crank radius. So here L plus R. Then the PQ plus QO, value of the PQ, L cos pi. The PQ, you can see from the geometry, PQC. So this is the right angle triangle, PQC. From in this triangle, you can see the value of PQ. PQ, that means the value of base. So as you know very well, the base upon hypotenuse, that is equals to cos phi. Base upon hypotenuse equals to cos upon phi. So the base is equals to base PQ is equals to hypotenuse into cos phi. That is hypotenuse, that is L, length of the connecting rod, the L cos phi. Similarly, QO. So you can see in this triangle, OQC. This is the right angle triangle. In this triangle, the value of OQ, So what is that? This is the perpendicular, this is the base, and this is hypotenuse. So in this case, you can see the base, that is Q, and hypotenuse is R. So QO, that means base, that is equals to hypotenuse into cos theta. So hypotenuse, that is R cos theta. So this is the value of QO. And separating the terms, that is R and common R from this R, and we have the value of R 1 minus K cos theta and plus L 1 minus K cos phi. We can also written here like this: x is equals to R 1 minus K cos theta plus L upon R 1 minus K cos phi. Now the R 1 minus K cos theta plus N 1 minus K cos phi. So here you can see this is like this. Now we have to calculate the value of 1 minus K cos phi. So from the triangles CPQ and CQO, CQ, that is equals to L sin phi is equals to R sin theta. L sin phi equals to R sin theta. That means that you can see this triangle CPQ. That means C. Where is the C? This is the C, and this one is the P, and this one is the Q. So this is the right angle triangle. From this right angle triangle, you can see here the value of CQ, that is equals to L sin phi, and which is equals to R sin theta from this triangle, R sin theta. Now here L by R, that is equals to sin phi upon sin theta upon sin phi, and L by R, which is length of the connecting rod to the length of the crank. It is the ratio of length of the connecting rod to the length of the crank, which is represented by a small n. So here you can see the n is equals to sin theta upon cos phi, sin theta upon cos phi, or sin phi is equals to sin theta upon n. This is the equation number 2. We know that the cos phi is equals to 1 minus K sin square phi in raised to power 1 by 2, or we can say that sin square phi plus cos square phi, that is equals to 1. We can also written here like this. And for calculating the value of 1 minus K cos phi, for the substituting the value of the 1 minus K cos phi in equation number 1. So first of all, we have to calculate the value of the 1 minus K cos phi from this equation. The cos phi is equals to 1 minus K sin square theta upon n square theta, because we have to substituted the value of sin phi, that is equals to sin theta upon n in this equation. And after this, the expanding this expression by binomial theorem, and we get the value of cos phi is equals to 1 minus K 1 upon into sin square theta upon n square theta plus and something plus other higher terms, and the higher terms are neglected. And now we have the 1 minus K cos phi is equals to sin square theta upon 2n square. This is the equation number 3. And substitute the value of 1 minus K cos phi in equation number 1. And after the substituting the value of 1 minus K cos phi in this equation, and we have the value of displacement of the piston, x is equals to R1 minus K cos theta plus n into sin square theta upon 2n square. This is the final equation. X is equals to R1 minus K cos theta plus sin square theta upon 2n. This is the equation number 4, or we can say that this is the displacement of the piston. Now we have to calculate the velocity of the piston. So after the calculating the displacement of the piston, differentiating this equation with respect to theta. So this is the differentiation of the displacement with respect to theta, that is equals to R is the constant that is written here, And the differentiation of this equation, the differentiation of 1 that is equals to 0 and minus cos theta. The cost differentiation of cos theta is equals to minus sin theta. The minus minus plus, that is sin theta, plus sin differentiation of sin 2 theta. Differentiation of sin square theta, that is equals to sin 2 theta. This is the constant which is divided by 2n. So this is the differentiation of dx upon d theta. Now we have to calculate the velocity. Velocity, that is equal velocity of the piston, which is represented by Vp, that is equals to the differentiation of the displacement with respect to time. So that is dx upon dt. Here we can also return this equation like this: the dx upon d theta into d theta upon dt, and the cancel out the d theta, and we get the similar equation. Vp is equals to dx upon dt. But in this equation, we substitute the value of dx upon d theta from the previous one, and d theta upon dt, that is equals to omega. That means the angular displacement with respect to time, that is equals to angular velocity. Here this is omega, and substitute the value of dx upon d theta from the equation number 5, and then we have the value of velocity of the piston, that is equals to r omega sin theta plus sin 2 theta upon 2n. This is the equation number 6, or this is the velocity of the piston. Now we have to calculate the acceleration of the piston. So as we know that the acceleration is the rate of change of velocity. Therefore, the acceleration of the piston P AP, that is equals to dVb upon dt. That means the differentiation of velocity with respect to the time, it gives the acceleration of the piston. So it also can be written here dVp upon d theta into d theta upon dt. The similar d theta can be cancelled out, and we get the similar equation dVp upon dt. So here the d theta upon dt, that is equals to omega. We have already discussed in the previously, and now substitute the value of d theta in place of d theta upon dt in place equals to omega, and here the differentiation of velocity, differentiate in the equation number 6, or equation number 6, or we can say that the velocity of the piston with respect to theta. So this is the velocity of the piston with respect to theta, that is equals to r omega cos theta plus cos 2 theta into 2 divided by 2n. This is the differentiation of equation number 6, or equation of velocity. And then we have the value of dVb upon dt, that is equals to r omega cos theta plus cos 2 theta upon n, because 2 and 2 both are cancel out. And the substitute the value of dVp upon d theta in the equation of acceleration of the piston, then we get the value of the acceleration AP is equals to r omega cos theta plus cos 2 theta upon n into omega, and finally the multiplied by the omega, that is r omega square cos theta plus cos 2 theta upon n. This is the equation of acceleration of the piston. So this is all about the displacement, velocity, and acceleration of the piston. Thank you.